Hi, today we're looking at section 5-1, identifying linear functions. So please take something out to write with. And remember, pause the video as you take your notes and complete the check it out problems at the end of following each of the examples. Our two learning targets today: I can identify linear functions and linear equations, and I can graph linear functions that represent real-world situations and give the domain and range. So some vocabulary terms: a linear function is a function whose graph forms a straight line. So we're looking for a straight line, and you see the word line in linear. And then a linear equation is any equation that can be written in standard form. Ax plus by equals c, where our a, b, and c are real numbers, and our a and b cannot be 0. Here we have a graph, and we want to say, is this graph a function? So we're going to look for make sure each x has a unique y, and in case in fact it does, we could also do our vertical line test, drawing a line down and intersects our graph at one point each time and the lines are drawn down. So yes, this is a function. So yes, and this helpful hint down here, again, this also forms a straight line. So therefore this graph is for a linear function, meaning it's a function that's a straight line. Here we have our first example. We want to identify whether the graph represents a function and explain. And if the graph does represent a function, is the function linear? Okay, so looking at our first example, A, we notice that each x has a unique y, and it is a linear, and it's a line, therefore it's a linear function. And again, vertical line test, very handy. Draw a vertical line. We have our grid markings there. Only intersects our graph at one time. Moving over to B, we see that, again, it passes the vertical line test. We can draw lines down, only intersects our graph in one point. So it is a function, but it's not linear. It's got a curve to it. And C, we have here, x only has one value. Our domain is just at x equals -2. So it's not a function because there's all these y's that x can be. A vertical line is actually on that line, so it's not a function. Here's your check it out. You've got 3 problems. Complete those and bring any questions to class. So now we're looking at linear functions. We have a table here of ordered pairs, and they're graphed over here. So is this a linear function? And this is a linear function. There's a constant change. We have a line that's formed. When we graph those points, it's a line. We can also look at a pattern here in the table to see if it's changing at a constant rate. As our x increases by 1, our y decreases by 3. So it's a constant rate of change. So here's another example. Tell whether the ordered pair satisfies a linear function and explain. So we had the ordered pairs, put them into a table. Sometimes it's easier to look at a table and determine if it is or not. So let's see if we have, looking at that, if it's going to be an ordered or a linear function. So we've taken our ordered pairs that we were given, ordered pairs here, and we wrote them into a table. So now we can look at the differences here and see what's happening. Notice our x's are increasing. We went from 0 to 4, 4 to 8, 8 to 12, and 12 to 16. Our x's are increasing by 4. Moving over to our y values, our y's are increasing by 3. So those are all constant changes. So in this case, it does satisfy a linear function. We have a constant rate of change for our x and our y values. In this example, again, we've taken our ordered pairs and we've put them into a table format, much easier to see for rate of change. Now let's go ahead and see the rate of change for our x and y values. So looking at our x values, our x's are increasing by 2 each time, so it's a constant rate. But our y, we decrease by 12, decrease by 4, then increase by 4, and increase by 12. So the y doesn't have a constant rate of change, so therefore, these points will not satisfy a linear function because it's not a constant rate of change for both our x and our y coordinates. Now it's your turn. We've already included a table in here for you, so you don't have to put these ordered pairs into a table, but you should know how to do that. So another way to determine whether a function is linear is to look at its equation. So we're looking at a linear equation. We talked about this initially at the beginning. Standard form is ax plus by equals c. So here are some examples. These are linear. We have x and y on the same side. And c's here. This is linear because we can just subtract y from both sides. And then here we can also add y to both sides. So these are all linear. Over here, this is nonlinear because x and y is being multiplied. Here, this one we have an exponent for x, and here y is in the denominator. Those are all three criteria that if they exist, then they're nonlinear. Linear has to be x by itself or with a coefficient, and y cannot have exponents or be in the denominator. So to summarize what we had here, x and y both had exponents of 1, x and y are not multiplied together, and x and y do not appear in the denominator as exponents or radical signs. And this is very important here. Keep in mind for any 2 points, there's exactly one line that contains both of them, which means you only need 2 ordered pairs to graph a line. So it just takes 2 points to define a line. So in this example, we want to tell whether the function is linear, and if so, graph the function. Okay, so to determine if it's a linear function, we need to first answer the question, can we write it in standard form? And if so, it's a linear function. So we have our initial equation here, x equals 2y plus 4, subtract 2y from both sides, and yes, we can put it in standard form, so it is a linear function. Our next step then is to come up with some ordered pairs. So we can pick some values. Since it's already solved for x, let's pick some values for y. So we pick 0, -1, -2. Solved for x, we end up with these 3 ordered pairs. Plot those points. And remember last time I said you only need 2 points to define a line. You could have just picked 2 points and plotted them. It's always good to pick a third one just to check and make sure you solved the equations correctly and got the right ordered pairs. Here's another example. Tell whether the function is a linear pair, and if so, graph the function. Can we write x, y equals 4 in standard form? So with this one, notice that x is being multiplied by y. And so we cannot write in standard form since x and y are multiplied together. Therefore, this is not a linear function. It is a function, just not linear. Tell whether the function is linear or not. This is your check it out. You have 2 of these to complete. 3 of them to complete. So for linear functions whose graphs are not horizontal, the domain and range are all real numbers. But in real-world situations, again, remember the domain can be restricted and the range may be restricted. Can't have negative distance, half of people. So some quantities cannot be negative, such as time. So that's going to be important to keep in mind when looking at real-world situations. So sometimes domain and range are restricted even further to a set of points. Example, number of people can only be whole numbers. We can't have partial people. When this happens, the graph is not actually connected. Every point, because every point on the line is not a solution, so it's going to be a discrete graph. However, you may see these graphs shown connected to indicate that a linear pattern or a trend continues. They made a trend line, or how it's trending. So here we have an approximate relationship between human years and dog years is given by the function y equals 7x, where x is the number of human years. You've always heard dog years, 7 to 1 human year. Graph this function and give its domain and range. So for this example, we have our function y equals 7x. We had to pick positive values for x. So we picked 1, 2, and 3. So our domain x has to be greater than or equal to 0, which then makes our range y has to be greater than or equal to 0. Plugging those into our function, we get 3 ordered pairs. And again, you only need 2, but it's not bad to pick 3. Plotting those points and graphing it, we have a nice linear function. Keep in mind you always want to put a header on your graph and label your axes. So human years is on the x-axis, dog years on the y. Now here's your check it out. If you have any questions, please bring them to class. So to summarize, keep in mind, remember that linear includes the word line. So it's going to be, you're looking for a straight line when you graph these functions. And a function may or may not be linear. We've seen some that were curved that are still a function, parabolas, and they're opening up or down. Standard form of a linear equation is in the form ax plus by equals c. And you have to make sure a, b, and c are all real numbers. A and b are not 0. X and y are not multiplied together. X and y both have exponents of 1, so to the first power, first degree. And x and y do not appear in denominators, exponents, or radicals. And then again, for any 2 points, there's exactly one line that contains both of those points. So you only need 2 points to make a line, but it's always good to pick extra points and plot those. Thanks. Bye-bye.